Hi everyone, welcome to Euron, and guys, in this video I'm going to talk about basic variable declaration and all of those stuff around this basic variable declaration. It's going to be a very first class for all of you, very first lecture for all of you after looking into installation and configuration. So I'll not discuss tough things over here. Obviously I'll try to go slow, and I'll try to discuss a little less, but yes, obviously whatever things is required to cover this particular topic, a variable declaration and type conversion and many more things around it. So I'll try to cover each and everything with my best. And at the end of this lecture, guys, in a dashboard, you all will be able to find out an assignment, and you will be able to find out an instruction to submit the assignment. So please look into those assignments and please try to submit it. We have already uploaded those assignments inside your dashboard. So let's get started, guys. Let me share my screen and let's start talking about a topic for a day. Now, so what we are going to see, what we are going to discuss over here is that how we can try to declare a variable. But before that, we will try to understand that what is variable, why we are going to use a variable, how memory allocation is going to happen with respect to a variable, what is our naming convention in general we try to use, what is like a constant, what are the different kind of a variable type, how we can try to do a variable type checking, many more things. It's not at all a complex topic. But yeah, it's a fundamental, and we are going to talk about those fundamentals in a practical manner. So first of all, try to open up your VS Code and don't get overwhelmed at all, guys. So try to open up a VS Code. I'm going to create a new folder. I believe this is your very first class. So I'm going to click on new folder and then Python English. I can write Python Sudhanshu and then English. Okay. Now, I can select a folder and then I can try to start writing a code inside my VS Code. Inside that, I'm going to create a Jupyter Notebook as well. If you have not done a setup for a VS Code so far, you can try to go ahead with the Google Colab. That's completely fine. So whether it's a VS Code or whether it's a Google Colab, so both is going to work for me, and you will be able to achieve a exact same goal. It's not going to make any kind of a difference as such for any one of us. You will be able to execute a code even over here and even over there. Now here, so what I will do is I'll just try to go and I'll try to create a file. So this is Python underscore basic, right? So .ipynb, so that it will be able to create a Jupyter Notebook. So ipynb, and then I'm going to click on code and I'll start writing a code. Now, just without writing a code, let me try to execute this one. So I can do shift enter or control enter, and it is asking me to select a Python environment. So whatever Python environment that I have, I can select one of those environment. In a later stage, as we all know that how to create a multiple environment going forward. So if I have to change the environment at any point of a time, maybe some different Python version, some different installation, I can do it any point of a time. So again, all these feature and facilities are given to you inside your Jupyter Notebook. Now, so coming back to our topic. So what we are going to discuss today. So we are going to talk about basically a variable declaration, right? Before that, let's try to understand what is a variable, by the way, for what purposes we are going to use a variable. So guys, all of us have to understand one thing, that why we are writing a code. We are writing a code so that I will be able to interact, I will be able to build, I will be able to develop, I will be able to process, I will be able to execute. Now, what you will process, what you will execute, obviously a data. Maybe I'll be reading a data from my Excel sheet, a doc file, a PDF, maybe like some sort of an integer, float, some sort of a calculation I'm going to perform, right, between a numbers. So at the end of the day, you have to process a data. Right? That's a bottom line. You have to process a data. Now, when you have to process a data, so you have to keep it somewhere so that your code will be able to access it easily. Just by calling something, your code will be able to access your data easily. As of now, obviously, we are going to start with the very small data, but going forward, our data set is going to be big, and we will be reading a data from some other sources, maybe from our databases, maybe from a S3 bucket, and a variety of sources. So here, like I said, the bottom line, guys, is to process something, right? This is the reason we are writing a code. This is the reason we use to develop some sort of a system. So we need, basically, we need a variable, or we can say that we need some sort of a entities where I can try to like store a data, and I can try to give some sort of a reference that, okay, so this is holding this data, right? For example, so if you have given money to someone, right? So obviously you can say that this XYZ person is holding this much value of a money. Simple, right? My money. Or maybe like if you are trying to calculate a net worth, you can say that okay, fine, this person, or maybe you as a person, is having this much of net worth. In a similar manner, so we try to create a variable, maybe A, B, C, D, or maybe XYG, or maybe with my name SUDH. So I can try to create a variable, and then I can try to hold a data over here. So I can try to hold a data over here. A different kind of a data I can try to hold in a different variable. So here we have variable name is equal to A, then B, then XYG, then SUDH, and Python is basically a self-typed programming language. For example, what is the meaning of that? Let's try to understand. So see, guys, when we are trying to declare some sort of a variable in some other programming languages, so we have to say that, okay, so what is a type of this variable? Means what kind of a data this variable will be able to hold. This is what we used to say. For example, we say int, let's suppose, in case of Java, C, C++, something like this, we used to say that, okay, so this variable will be able to hold only integer type. So that we are restricting that, okay, fine, so this variable will be able to hold only a integer type, not any other kind of a data set. Now, this kind of a bottlenecks are not available in Python. In Python, you will simply write A is equal to 10, and Python will be able to understand that, okay, you are trying to store integer into A. So A is holding integer data type. Whereas in other programming language, so we try to put a restriction beforehand that, okay, you will not be able to store any other data except this one. So Python is a self-typed programming language. A lot of things you will be able to find out that Python can understand automatically without even telling you or without even letting you know. Now here, so A is a variable, B is a variable, XYG is a variable, SUDH is a variable. So with any name of my choice, I'm able to create all of these variables, and then I will be able to store a data. So for example, if I'm saying 10 is holded by whom? A. So this is how I can try to represent that A is referring to a data or a value inside a memory is equal to 10. Whenever I will call A, it is going to give me 10. Similarly for B, so it's, let's suppose 10.26. So basically it's represented by B. And then this 5.00, let's suppose. So this has been represented by XYG. Maybe this quotes ABC. So this has been represented by SUDH. So this is how inside a memory it is going to store your values and its reference, which we are calling technically as a variable, right? As a variable, just by your, like your name, right? So your name is, you can consider as a variable. So whenever someone calls you, your entire body moves, or your entire body start giving attention. So when someone is calling you, right? So basically they are calling you like as a whole person by your name. So in the similar manner, you're calling the complete value by its variable name that you have given to a data. So now let's try to understand it in a practical manner, that what kind of a variable I will be able to create, a different kind of variable I will be able to create over here. So here we can come and then we can try to say that A is equals to, let me close all of these unnecessary tabs which is popping up. So here I can say that A is equals to 10, simple, right? So whenever I'm going to call A, it is going to give me what? It is going to give me 10. Very simple, right? Very simple. Now I can go and I can try to check what is the type of A, by the way. So type of A, type is basically a inbuilt function. Don't get confused, never get confused. So type is basically a inbuilt function. Now when I say type of A, automatically, right? Because I'm not saying like what kind of a data A is supposed to hold. I never said that, right? I've never trying to mention that. So here when I say type of A, right, type of A, so automatically it will be able to understand that, okay, so type of A is basically a integer, right? Type of a is basically a integer. Now, so when I'm trying to say that, okay, so here, so this is called as self-typed. So 45.56, and then when I check, so what is a type of basically, not this. I'll just switch off my auto completion, at least while coding. So what is the type of B? And T should be small, type of B. So it is automatically able to sense that data, the kind of a data which B is holding. So it's having a boolean in its nature. Okay, so another kind of a data type that we are talking about over here is a floating point number data type. So again, integer is one of the type, and floating point number is another kind of a data type that you will be able to find out. Now let's suppose I'm going to write over here C and single quotes, and then I'm going to write SUDH, right? So here, if I'm going to check that what is a type of this C. So type of C is basically a string. So by default, Python will be able to understand that if something is been wrapped inside a single quote, so it is going to be a string. Similarly, let's suppose if I'm going to write D and D is equals to, so if I'm going to say that D is equals to SUDH, so in that case, again, so D is not with a single quote, maybe D with the double quote. And if I'm going to write SUDH, and if I'm going to check what is a type, what is basically a type of this particular D, so again, it is going to be a string. So as you can see that whether I'm using a single quotes or I'm using a double quote, so Python compiler will be able to recognize it as a string. So a string, if I have to create, I can try to create it with the single quotes and with the double quotes. Now there are tons of operations we are going to do just with respect to a string. So in your syllabus, we have a separate dedicated chapter for a string. So where we are going to explore a lot of things with respect to a string. As of now, I'm just talking about a declaration and checking the data type of a particular variable. That's it. I'm not talking about anything else over here. Okay. So this is fine. A string we are able to create and we are able to check its data type. Now there is something called as triple quotes as well, but I'm not going to talk about that triple quotes for now, maybe in a future. So upcoming classes, anyhow, I'm going to talk about a triple quotes as well. And again, so double quotes inside a single quote inside a double quote, all those things I'll be talking about in your upcoming classes. Now here, so step by step, obviously. So when I'll be talking about a string specifically. Now here, so there is another kind of a data type that you will be able to find out. Let's suppose I'm going to create f is equals to 4 plus 5j, right? So, and then if I'm going to check what is a type of f, so it is going to tell me that its type is equal to complex. Now, so what is this complex, by the way? So I believe we all have studied a complex number in our childhood. So where complex numbers are nothing but a combination of real number and a imaginary number, right? Combination of real number, imaginary number, and imaginary is been represented by root of -1, or I square is equals to -1, which is called as iota in our like a childhood. So we have discussed that. Now, similar kind of a complex number you can try to create even inside a Python, and Python will be able to understand it automatically. As you can see, as it's a self-typed programming language. So here, when I say that 4 plus 5j, when I say that 4 plus 5j, so automatically Python is going to understand that this is basically a real part of the data, a real part, and this 5 is nothing but it's a imaginary part of the data. Because of this j representation, there is nothing called as I. So I will be treated in a different way inside a Python, but to represent any complex, like a complex numbers, imaginary part, so we try to use a notation called as j. So with j, small j again, right? So with a small j, Python will be able to understand that this part is basically a imaginary part, which is available over here. So this is how you can try to create even a complex number. And then going forward, so you will be able to do all kind of a calculation even with respect to the complex number. It is possible to extract a real part and a complex part out of this one. So here I can say that f dot real, so it's an inbuilt function which is available. So it is going to give you a real number, which is a 4. If I'm going to say that f dot imag, so f dot emag, it is going to give you basically 5. Now 5 is nothing but it's a complex part as of now. Yeah, let's just try to understand this part. Okay, fine. So imaginary part is fine, complex part is fine. Then there is, right, there is another data type you all will be able to find out, and that data type is called as boolean. What is boolean? Let's try to understand. So here, if I'm writing that E is equals to TRUE, true, T capital again, yeah, T capital. So Python is a case sensitive programming language. So capital letter, small letter is been treated in a different way. It's not same. It's not going to be same at all. So here, if I'm writing E is equals to true and type E, right, type E. So it is going to tell me that it's a bool. Bool means boolean. Boolean means true and false. This is called as basically booleans. So here, if I'm going to write F is equals to FALSE, false, again F capital. And again, if I'm going to check what is a type of like a, what is a type of basically F. So it is going to tell me that type of F is basically what? So type of F is basically a Boolean number, which I'm going to talk about. As simple as that, right? So type of F is basically Boolean. Now, so here what happens is that whenever, right, whenever I'm going to write a true plus, which means that I'm trying to do a arithmetic operation. So whenever I'm writing true plus false, so what happens? It is going to give me 1. Why and how? So internally, whenever I'm going to call this arithmetic operation, so it is going to convert this true into 1 and false into 0. So 1 plus 0 is equals to 1. So it is trying to do auto typecasting. Typecasting means it is trying to convert one data type to another data type. So basically true will be treated as integer 1, false will be treated as integer 0. If I'm trying to perform a arithmetic operation only and only in that particular situation. Okay. So true plus false, 1 plus 0 is equals to 1. This is something which I'm able to access, which I'm able to get. Fine. We'll be using that a lot. We'll be using that a lot. So just wait and watch. So 10 into, I can write maybe a false, FALSE, 10 into false. And obviously I know 10 into 0 is equals to 0, right? Similarly, I can write 10 into, and then I can write maybe a true over here. So I know 10 into true, which is like a 10 into 1 is equal to 10. So this is something that I will be able to get. So whenever you are going to do arithmetic operation, so it always try to convert it into its integer equivalent, and then it is going to perform that arithmetic operation. There is another data type you will be able to find out, and that data type is called as NONE, none. Now, what is the meaning of this none, by the way? So none doesn't mean 0, because 0 is different. None doesn't mean even a false, because false is different. None is a data type in itself. It simply means that no numbers, nothing basically. So no data. So here, if I'm going to check what is a type of this G, by the way, so it is going to tell me that it's a none type. And so none type is a data type in itself, which is available into a Python. So don't get confused with this. None type is not equal to 0. None type is not equal to false. As simple as that. So please keep these things in mind for future purposes. So none type is a different data type altogether. Okay, that's completely fine. So we are able to like check what is the data type of G, what is the like none type which is available. Now, so let's try to understand a couple of more different kind of a chapter over here. So here now we are aware about a couple of data types. So we have seen that what is the data type, what is the variable, all these things we have seen. So we have seen integer, we have seen floating point number, FLOAT, floating point number. We have seen basically a string. We have seen a complex. We have seen basically a Boolean. We have seen a none type, right? We have seen a none type. So these kind of a data type now we are able to see. Now we know that how to declare a variable and then like a little bit of operations. Now I know that how we can do a little bit of operations. We also know that how I will be able to check a type of the data. Simple function, right? Simple function. So type function, just call type function, pass your data or pass your variable name, and it will be able to check what is the data type which Python compiler is able to understand out of your declaration. As simple as that. Yeah. So this is where type comes into a picture. Now let's try to understand one small function which is called as ID function, which is related to a memory. So like I said, that whenever you are trying to create a variable, so it is trying to store somewhere, right? It is trying to store somewhere. For example, if I'm writing 10 and if I'm saying a is equal to 10, so obviously a is referring to 10 and 10 is stored in some of the physical memory. Now let's try to understand ID. So what ID actually represents. So here, let's suppose I'm writing a is equals to 10, and then if I'm saying ID of a, ID of basically a, right? ID of basically a. So this is going to give me a number. Now this is referring to a memory address. Memory address. So somewhere we are trying to store some data, right? Somewhere we are trying to store some data. So this is referring to a memory address. Now here, if I'm going to write a b, right, and b is equals to a, if I'm trying to say, so b is equal to a means a is equal to 10 and b is equal to a. So b is also equal to 10. Now if I'm going to check what is the ID of b, by the way, what is the ID of b, by the way? So you will be able to find out that ID of b is same as a, right? Why? Because a is equal to 10 I have written. So let's suppose we had basically like a 10 and we are referring to a over here. So a is equal to 10. And then we are trying to say that b is equal to a. So when we say b is equal to a, it simply means that b is also referring to a exact same location. So whenever you say ID of a, you will get this number 140712277230664. So 1407122772306664 is, which is exact same. So this number and this number is same, meaning is that b and a both is referring to the exact same location. As simple as that. Yeah. So both of this is basically referring to the exact same location. So this ID is going to give you this location. Simple, right? Memory allocation or memory address it is going to talk about. It's a very simple function, very basic function, right? But yeah, so this is going to help you out in terms of building your little bit of understanding. Okay. Now let's try to understand a couple of more things with respect to the ID. Now here, so if I'm going to say that b is equals to like 20 and a is equals to 10, right? B is equal to 20 and a is equal to 10. Now if I'll try to check what is the ID of like a and what is the ID of b. So obviously ID of a and ID of b is going to be different, right? As you can see. So both are referring to a different memory address, means 20 is been stored in a different memory location and 10 is been stored in a different memory location. So that's the reason. So when you say ID of a and when you say ID of b, both are technically giving you a different ID over here. Yeah, both are giving you basically a different type of IDs over here. Okay, so that's pretty much good. And now we know that how I will be able to understand or how I will be able to extract the ID, right? The ID of a particular data or variable that we are trying to store at any point of a time. Okay, that's completely fine. Now let's talk about another topic with respect to a variable, which is the beginning of the topic, I would say, which is something called as type conversion. So let's suppose there is a data, right? Let's suppose there is a data A, which is holding 10. I would like to convert this A into some different type. Yeah. So A is having what type of the data? So I can check. So what is the type of A? Type of A is basically integer. Now what I want is I would like to convert this type of A, right? Type of A, which is an integer, into a floating point number. So for example, A, which is an integer, I would like to convert it into a floating point number. So what I can do is, so I can try to call float, I can pass A over here and execute. Now you will be able to see that A became 10. Yeah. So this is a type conversion which I'm talking about. Similarly, so let's suppose if I would like to convert A into a string, so I can call what? I can call str function, and then I will be able to convert that A into a string. So again, you can see that now around 10, we have a quotes, we have a single quotes, right? So into a string, I'm able to convert. Now maybe I can try to call a complex over here. So not compile. So complex, 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 and then A. So I'm able to convert this A into a complex number. It's a complex number representation where my imaginary part is basically what? It's 0, right? Imaginary part is 0. So I'm just trying to convert A into a different kind of a data type. So it's possible to do a type conversion, but again, with certain conditions. It's not like everything and everything you can convert from one type to another type. For example, let me give you that example as well. So for example, let's suppose if I'm trying to say that A is equals to SUDH, let's suppose, yeah, A is equal to SUDH, and B is equals to, let's suppose, inside our quotes, I have 30, yeah, B is equal to 30. Now, can I convert this B into an integer or maybe a floating point, maybe into a complex? Yes, I can do that. So here, if I'm going to call as B, what is the type of B? So type TYPE, type of basically B. So what is the type of B? By default, it's a string, right? By default, it's a string over here. This is the type of B. Now, if I have to convert this particular type, which is a B, into maybe an integer, let's see whether I will be able to do it or not. So integer of B. So yeah, I'm able to convert this string into an integer. Now I can try to call integer of maybe, floating point number of B. So float of basically B. So I'm able to convert this string into a float. I'm able to convert a string into an integer. Then I can try to maybe call like a complex of what? Complex of B. So I'm able to convert even B into a complex number, right? I'm able to do that. But I have A. Inside A, what value I'm holding? I'm holding SUDH. Now it's a string, right? I would like to convert this into an integer. Will I be able to do that? Let's try this out. So integer, an integer of A, obviously I will not be able to do it. I'm going to get some error. Yeah. So as I said that when I had a value A is equal to SUDH, I'm not able to convert, right? In value literal for the integer with the base 10 SUDH. So it's not like everything you will be able to convert into everything. Obviously it depends upon the compatibility. So SUDH, you can't convert it into an integer, but yeah. So if you have something like some numbers inside a quote, single quotes or double quotes, in that case, obviously you will be able to do a type conversion. That is practically possible. You all can do it. So hope type conversion is fine. And again, this is just a beginning of the lecture, guys. So obviously we are going to see like tons of situation, tons of scenario going forward, right? Every day we are going to see some new use cases. Every day we are going to see some new example. This is how we are going to like build this entire things. Yeah. Okay. Now, moving ahead, so there is a topic called as basically a floating point precision issue. So what is that, by the way? So let's suppose I'm writing point 1, right? I'm writing point 1 and then I'm writing a point 2. Now if I'm going to execute it, so I was expecting point 3, but it is not giving me point 3, right? It is not giving me point 3. It is giving me some big number. So this is something called as floating point precision issue. So this number is obviously not equal to, if I'm going to check, is it equal to 0.3? Obviously no. So generally like people will give you that, is it equal to this? It looks like it is equal to, right? It looks like in a very first place, but is it really equal to this one? No, not at all. This is not at all equal to this one. This is what you will be able to get. This is what you will be able to understand. So this is not equal to this one, guys, at all. In any situation, in any circumstances, it is not equal to this one. Now here, this particular issue is called as, like I said, like I have mentioned, that this issue is basically called as floating point precision issues. Now I will try to talk, and again, so how we can try to remove it? So we can try to use some of the mathematical function. We can try to chop down the sum of the numbers, or maybe we can try to call the round off. This is where a mathematical function comes into a picture. So there is a package. There are a lot of packages in Python with respect to mathematics, but there is a specific package called as math package. Let's go ahead and talk about that math package. So import what? math math. So there is a package called as math package, which is available inside a Python, and which is going to help you out in terms of doing a lot of mathematical calculation, right? A lot of mathematical calculation, which we are going to use it again and again. Almost every time we are going to use it. But yeah, for now, let's see couple of operations. Again, I'm not going into a depth of everything, guys, because we have to discuss a lot. We have to cover a lot. And again, it's a day zero for all of you. I know most of you are just trying to start with a Python code. So I just don't want to discuss complex things over here, right? Because I know that you all will be able to learn, or you all will be able to excel into a complex things once you understand basic. So I will just try to go into a very basic, and then I'll try to increase the label as we will progress inside this entire lecture, so that you will learn, adopt, settle down, then again learn, adopt, settle down. So in this way we can try to move into it. So here import math, and then if you are going to call math dot and then maybe a pi, you can try to call as of now. So math.pi, it is going to give you a value of pi. You can try to give math.e, so it is going to give you a value of exponent over here. Math dot, there are like tons of function, like I said guys, so which is available over here. So maybe I can try to call math.pi. I have called radians, I can try to call. So this is going to calculate a radians for something. For example, let me give you this example. So here I'm going to call math.sine, right? Sine function, and then I'm going to pass some number. So this number is representing basically a radians, and then this is going to give you what is the sign of this particular number, which has been represented in a radian. For example, if I'm going to call math.floor, so math.pi, it is giving me what? It is giving me 3. So what is pi value? 3.14. So what is the floor? Floor is basically 3. Similarly, so if I'm going to write math dot like is close, so this one and this one is close. So obviously this 2 is close to each other, right? So is close. Whatever function starts with is, it is going to give you true or false. Similarly, I can try to call math dot, and here, so I can try to call maybe a cosec theta. So here, yes, I'm able to like pass some numbers. I will be able to get a cos. So this number is nothing but it's available into a radians. Now I can try to call math dot log. So logarithmic of base 10, base 2 or base e, I can try to call, and it is going to give you the final result. So math function is having a lots of utility going forward that you all will be able to find out. But yeah, so this is all about the math library, and I believe like we are able to understand a basic of Python over here, guys. So let's continue with the class. I have already attached an assignment inside your dashboard, so try to complete your assignment. So assignment which I am giving you, keeping one thing in mind, that it is going to help you out to do some sort of a work by yourself, so that you will be able to do some exploration. You will try to write a couple of lines of a code initially, obviously one single line of a code, and then you will be able to build something on your own. So that's a whole mindset, that's a whole idea behind giving you this assignment, which is already available inside your dashboard. This is how we are going to progress. I'll take the class, I'll give you assignment, I'll give you the quizzes, I'll give you the challenges going forward, a lot of challenges inside your dashboard itself. Each and everything you will be able to find out. So with that, guys, thank you so much. See you again in my next lecture. Till then, bye bye. Take care, everyone.